Look, I'm just a geologist. I like rocks. I love rocks.
Hello, everyone, and welcome to the Geology Flannelcast. My name is Steve.
Hey there, everyone. This is Chris.
Good day, everyone. Hello. I'm Jesse.
Jesse, people are going to start being worried about you. Like,
Yeah,
Well, I was thinking about this earlier, and I was like, oh, got to come up with a good opening. And then I'm like, all right, I'll just wing it. And as it goes, whenever you try and wing anything, it just falls flat.
No, that's sometimes when the best stuff comes out. You're just in that flow state, that flow podcast state.
Yeah, I was gonna say good morrow, but I don't think that really works.
Anyways,
yes.
you start thinking for next week.
Yeah,
Welcome everybody to the premier geology podcast, the Geology Flannelcast. Thanks for downloading the episode and hanging out with us today.
Yeah, we always appreciate it.
Yeah.
We are talking about the Appalachian Mountains yet again.
We got another multiple part topic again. There's so much information in the last podcast. We said, you know what, we got to break this up into at least 2 episodes. So that's what we're doing today. Today's the second part of the Appalachian Mountain saga, if you may.
Ooh, I like saga.
I like saga too.
Yeah.
It's saga to me, baby.
So, all right. So we should recap in case you didn't listen to part 1. Number 1, you should listen to part 1. That would probably be very helpful, to listen to this one. But in case you're not going to listen to part 1, we can give a little 30-second summary. We talked about the Grenville orogeny, which happened like 1 billion years ago, and that was kind of like the precursor for the for the Appalachian Mountains. And then there's 3 distinct mountain building events that are seen in the Appalachian Mountains during the Paleozoic era. We have the Tectonic orogeny, the Akkadian orogeny, and then the Alleghanian orogeny. So we talked about in the last episode, we covered the Tectonic and Akkadian orogeny. The Tectonic orogeny and island arc system collides with Laurentia, which is basically North America, the modern day east coast of North America. The Akkadian orogeny, that's when a microcontinent named Avalonia collides with the modern day east coast of North America, which brings us up to the Alleghanian orogeny. So who wants to kick this off?
Which of the 3 is your favorite?
Ooh.
You know what, the volcanoes are pretty cool.
I always forget about them. They are pretty great.
We talked last episode about we had a debate about where the had you guys ever seen the bentonite layers from it turned into bentonite. Bentonite's a type of clay, but it originated as volcanic ash. And we see like we call them like these little like stringers of volcanic ash all over the East Coast, and that's kind of telling us in the rock record, like, hey, the volcanoes are coming. Kind of like Paul Revere off in the night, the British are coming. Well, the bentonite stringers are like the volcanoes are coming.
Yeah, bentonite if by sea.
There you go.
I mean,
pushing it.
The one-liners, ladies and gentlemen. The one-liners. Just keep on coming. All right. So the Alleghanian orogeny, and this is the one that kind of puts up, this is the final, the third orogenic event that's found in the Appalachian Mountains, right? So it starts off in the Carboniferous period, and it goes and extends a little bit into the Permian period as well. So we're dealing with a time frame about 325 million years ago to about 260 million years ago. And so what ends up happening is we get a lot of continents start colliding together for this one. All right. It's kind of a hot mess, to tell you the truth.
Earth bumper cars.
Yeah, exactly. I do say that. I say it's like bumper cars. When you're playing, when you're on playing in bumper cars, whatever, there's always that cluster in the corner or whatever, where there's like a big pile-on of cars, where there's like 10 cars, and you got to wait until the outer cars start peeling off for for the people in the middle to get out, and it's a giant mess. And that's actually what happened kind of with the Appalachian Mountains during this the Alleghanian Orogeny. We had everyone was in the mix pretty much, but
because it leads to everyone being together.
Yeah. So
why can't we be friends?
Well, they were,
Why
but then
can't
they're like,
we be friends.
Nothing gold can stay, Pony Boy. Was that the line from The Outsiders?
It is. It was.
Nothing
Yeah.
gold yeah.
That's...
Not even the Beatles could stay together. It's
Oh shoot! That reminds me. I want to say, did I talk about the gold rush
which one?
during? So the first one. The first gold rush.
We have a little addendum for last week. Is that what you're getting at?
What's that? Yeah. Did I talk about it?
No, we did not talk about any
No.
gold last week.
Oh, I meant to.
All right, so let's go ahead. The stage is yours.
Well, I wish it wasn't. So the very first gold rush in the U.S. was in North Carolina.
Okay.
And it was in like the western part of the states, or yes, sort of west, sort of south. I'm trying to picture it in my head. I'm all flummoxed. Yeah, so it's like, if you picture North Carolina, where Charlotte is, it's a little bit east and south of Charlotte.
Mm-hmm.
And you find these gold deposits in southern North Carolina, some parts of South Carolina, but also in Georgia.
Mm-hmm.
And so we should also just stick a pin in this. The next time we're down in Georgia visiting you, we should go panning for gold.
Yes.
It's up in this town of Dahlonega.
Yeah, that's the I'm glad you said that, because I was trying to think of what the name of that.
On a total other sidebar, I'm building a battle robot that's called the Prospector.
Ooh.
It's got
You're building. Okay,
it's got a rock hammer for a weapon.
He's not building a robot.
I swear to God, I am. I'll show you the pictures.
What a great name for a battle robot,
right? And it's me, my brother, and my cousin, and we're all last name Petersons, so we're gonna call it Stinky Pete Petersons, who was the prospector in Toy Story 2.
Oh, okay. I didn't know that. Not up to date on my Toy Story 2 trivia, but
yeah, it's only 25 years old, so
yeah, right.
Anyway, sorry, carry on.
Yeah, so
panning for gold, I'm in.
Yeah, so Dahlonega, the Dahlonega gold was thought there's a connection with the Akkadian orogeny. Sorry, I'm very rusty on this because I had it last week and now I'm like blanking on exactly. It would be the Akkadian orogeny. So there was some thought that the gold, the placer deposits were from the uplift of some of this when Avalonia accreted onto Proto North America. You had some abduction, so you had some uplift.
Okay.
And you brought up some of these quartz veins, which is where you find, these golds that often emplace themselves. And so you get these placer deposits in the streams that are eroding off these uplifted terrains from the Akkadian orogeny. So there's this connection between the uplift of the Akkadian. I want to say it was the Akkadian. I don't think it was the Alleghanian. I think it was the Akkadian that left the gold from the first, basically two major gold rushes in our country's history, which would be in North Carolina. In North Carolina was in 1799, and Dahlonega, I want to say it was like the 1820s. But they were still mining gold. They were commercially mining gold down until the mid 20th century.
Hmm.
In 1950s probably. I don't know off the top of my head, but yeah, the last active commercial mine was into the 20th century, but it's estimated mid 20th century that they pulled out almost 25,000 kilograms of gold, which,
Holy cow.
Whoa.
yeah, I don't know what the conversion is to American dollars, but a lot.
It is.
So, it's 870,000 troy ounces, and the price of gold per ounce today is $1,700. Whew. So just actually the price per kilo is 56,218. There's 24,000. That's $1.3 billion worth of gold.
Wow. In today's money. That's pretty cool.
In today's money. Yeah. So there is this connection with the resources and the economics, I think is sort of the big story here, that, when you have the Alleghanian Orogeny, which we're talking about now, you start creating the basins where we're going to get swamps that form to the west of the mountains. Am I stealing your thunder?
No, I was waiting for you to say the word.
Oh, no, the swamps, one of the products is methane. And so we get a lot of natural gas.
Yes, that's
earlier, prior to the Acadian orogeny, as the Acadians coming in, we have the Eastern Iapetus Sea that separates Laurentia from Avalonia. And, it's in some of these seaway, and there's actually a seaway that forms then a little bit west, is where you get the emplacement of, you have a lot of plankton and things that are alive in there, a lot of little single-celled creatures, little I guess foraminifera, and when they die, their organics turn into the oil that is, the oil we have in Pennsylvania, which is all emplaced during this time. And a lot of the faulting from these orogenies acts as the traps. I mean, you have some salt caps too. There's actually salt domes are sort of a big part of this when the oceans dry up. But the faulting also acts as these structural traps for the oil. And we've talked about the first commercial well in Pennsylvania and whatnot. But the salt domes, I mentioned this a couple episodes ago, that the salt domes, these they're used for methane reservoirs today. We store natural gas in these old reservoirs that we're pulling out of the ground today. Pull it out, pump it back in. As it goes.
Yeah, and not just Pennsylvania. I mean, you get it into New York, you get it down in West Virginia. I guess a little bit in Kentucky. Is there oil in Kentucky?
A little bit, yeah.
You get Ohio.
Ohio too. Yeah. So anywhere you have that Marcellus, Utica, shales, but I guess even shallower than that. But yeah, pretty interesting how much money came out of this one orogeny. You're talking just over $1 billion just in gold, and then you take in all of the oil, gas, and coal.
No,
I said it.
Forgot all about it.
I forgot all about it. But seriously, I mean, that would be an interesting paper. This is how much money came out of the Alleghanian Orogeny.
It would be an interesting paper, yeah.
All right, I'm on it.
So when we have during the Alleghanian Orogeny, what we have happening is, at least on the east coast of North America, one of the main factors is that North America collides with Africa, right? Or specifically Gondwana. And like I said, but all this closes the Atlantic Ocean up, and this is the formation of Pangea. So we were looking up some of the stats, because there's some conflicting information out there, gentlemen, about
What?
Yes. There's some conflicting information out there about the height of the Appalachians when, right at the Alleghanian Orogeny, when they were basically baby mountains.
Can we all agree they were taller than they are now?
Yes, we can agree that they're taller than they are now.
Somewhere between the Alps and the Himalayas.
Yes. Specifically, well, I was reading well, I guess I should phrase it like this. You always hear like people, I had heard that the Appalachians were as high as the Himalayan mountains during this orogenic event. But then there's some other estimates out there that specifically some journal articles that there's some other journal sources out there that say that it was about as high as the Andes Mountains. So yeah. And so you're looking at, and they specifically this one journal article, this is from Rudy Slingerland and Kevin Furlong back in 1989, stated that there was the Appalachians had a average relief of between 3.5 and 4.5 kilometers, and it looks like they're about 250 to 300 kilometers wide. So I guess so relief, average relief from 3.5 to 4.5 kilometers. That's pretty tall,
Yeah, I mean that's not messing around. And there, I had classes with both of those professors.
Oh, it's your alma mater, man.
Yeah, that's what I was showing my T-shirt here.
And you got your T-shirt on, yeah. All right.
Yeah, so just for reference, 4 kilometers is that's over 13,000 feet. To throw it into some imperial units, which are my favorite. You do see, I was reading something about one of the reasons the relief is a little bit steeper in the south versus the north. Have you ever known this?
I go ahead.
I mean, we can, maybe you have a better explanation, but what I was reading, so when Proto-Africa was running into Proto-North America, as they were approaching each other, their initial contact, they actually started, there was some side-to-side motion where Africa was moving south relative to North America. And then it sort of made this clockwise rotation in the south, and then sort of pushed into North America. So the initial contact or collision was in the south. That's it. I didn't really get into the nuts and bolts of, there were some vector diagrams that I didn't have the mental capacity to deal with. But the tallest peaks in the Appalachians are down, the tallest peak would be Mount Mitchell, right, in North Carolina.
Yeah, right outside of Asheville.
Yeah, which is a little over 2,000 meters, so like 6,600 feet. And then you have the Great Smokies, and even up into like Eastern Kentucky and West Virginia, you have some steep relief there, and that's part of it. They're maybe not super impressive.
Now, I thought a lot of some of that was attributed to the lack of erosion based on glaciation. Am I wrong? I guess I'm wrong.
Silence.
Based on your face.
I don't know. I didn't know that. I had never heard that.
Just that, the
But-
more northern hemispheres, the more glaciers you have, the more erosion you get.
I mean, you still have like up in, further up north in New England, you still have like Mount Washington, that's 6,200 feet.
Yeah,
I
that's
believe.
all right. Then never mind. I'm gonna stop
I
talking.
mean, they were definitely carved out by glaciers. We know that.
Yeah.
But I don't think.
An interesting question about like the ice sheet. So during the Pleistocene glaciations, during all of the glacial events, the Laurentide ice sheet never makes it any further south than the northernmost part of Pennsylvania.
Mhm.
But would you still get during these ice ages, like, are you getting little mountain glaciers forming, say?
You have to be, right? Yeah.
In the Appalachians and in like the Great Smokies? Are you getting?
You have to, because remember, even last week we were looking at pictures up in the Adirondacks for the for the Patreon the extra we did afterwards. We were looking at was it what's the white sides or white face up in the Adirondacks? Yeah, up in the Adirondacks, and there's you could see the cirque that was carved out of the side of that. So
that's
an alpine glacial feature.
Yeah, but that's in New
Yeah.
York though. That's where the
That's
Laurentide sheet might have made it that far.
No. But what was your question? How did you phrase your question?
Can we get alpine glaciers further south?
Oh, further
where
south.
alpine glaciers
Oh, okay.
form. But I guess, I mean, even when they were, if they're 13,000 feet or 14,000 feet, you're definitely getting alpine glaciers up there.
Yeah.
Although, let's think. Yeah, you would.
I mean, just look at,
you go in
and just look at like modern day. Oh, I guess never mind. I'm sorry. I was going to say modern day Antarctica, but then you have that's in the ice sheets as well. So never mind. Forget that.
So that's a whole different ball of.
Yeah, that's it.
We should have stuck to our outline that we wrote in our Word document.
Yeah, we got off track here.
Yeah. Speaking of Word documents. Oh yeah. Awesome segue.
Yeah.
Formatting formula, www.formattingformula.com or YouTube/C/formatting formula. Actually, gentlemen, just this week, the Formatting Formula updated their website. They have a brand new website. Looks all fancy and fresh and new. Not once did I see the Geology Flannelcast on there, but I guess that's because they sponsor us and we don't sponsor them. It's probably a good reason.
Usually how it works. Yeah.
Fair point.
But yeah, check out the new website, formattingformula.com. Or if you're just looking to figure out your own word issue, please check them out on YouTube. They have tons and tons of videos out there on all different kinds of common problems that people have, all the way up to like the super complex problems. So please check them out, formattingformula.com or YouTube/C/formatting formula. If you do check them out, please let them know the Geology Flannelcast sent you there. Put a comment in their YouTube videos or something. I don't know. Somehow, some way we get credit. That's all I'm looking for is credit. So
Yeah, I'm not asking for much.
No. So back to our outline.
Well, I want to add some more things in here that aren't in the outline. So
Yeah, me too. I've got some other stuff.
yeah. So we should also note that I think we kind of talked about this at the end of the last podcast, but when we call this the Allegheny Orogeny, when these mountains went up, it wasn't just in North America. We see this mountain chain continuing over into the Atlas Mountains in Africa, and then up into like Scotland, and then up to in the UK, and then up towards up into Scandinavia. So it's all from the same mountain building event, all those different chains. And they were well, we'll talk in a couple of minutes about how that whole thing got split up.
Yeah.
Once again, nothing gold can stay,
No, it would be nice though. Yeah. So one of the interesting things is that you have the the collision here, and you have the formation of Pangea. And so Pangea is really interesting in that you have this supercontinent, right? So this is part of that supercontinent Wilson cycle, where you have supercontinents forming and splitting up every, what is it?
200
million years.
200 million years, give or take. What's a few million years? But the interior of this continent is pretty dry, right? Because you're so far from moisture.
I'm really happy. I was going to ask you to talk about this.
Oh, wow. Yeah. So you have this like interior, like desert, but on the edge of the uplift, right to the west, to the west of the mountain, you have a lot of shedding, and you have these swamps that form because you have moisture and whatnot running down the western slopes. And so you get all this erosion and we're going to talk about the rapid erosion, right?
Yeah.
But you have all these swamps that are forming, and it's a really interesting time because just in the Devonian, right before this is when we start getting land plants really taking over, and leading into this orogeny, you have all these land plants that are sort of colonizing land, or evolving onto land. And at or right after this orogeny, you have this combination of effects where you have all this, you're creating these foreland basins. So when the mountains fold, you create these sort of down warped areas, and they act as just collection points where you have these huge swamps that are forming. So you have all of this plant life that takes over. And plants are really good at pulling in CO2 when they're alive. And in swamps, you have very low energy. There's very little moving water. And so when the plants die, they pile up and they don't decompose. And so any CO2 you're pulling out of the atmosphere, you're basically converting it into carbon and then burying it, which I'm not even going to talk about, becomes coal. The more interesting part of this story is that you have this combined with the weathering of the mountains, which also pulls down CO2. So at the end of the Carboniferous, we go into what's called an icehouse world. It's this major glaciation because you've pulled so much CO2 out of the atmosphere. I like to call it the overlooked glaciation. Everyone's all about the Pleistocene. Let's talk about the Carboniferous. That's my motto. Let's talk about the Carboniferous.
Let's just talk about the Carboniferous.
But it leads into sort of the Permian. So you go from the Carboniferous to the Permian.
I'm sorry. I'm just envisioning a mug with Jesse's likeness on it. That's my motto. Let's talk about the Carboniferous.
Why are we talking about
We'll work with you to get like an after school special about this one, right?
Yeah.
Sorry, carry on.
No, but it's just this really interesting time. And this ice house at the end of the Carboniferous into the Permian was one of a friend of the podcast, Alfred Wegener's lines of evidence for continental drift.
God rest his soul.
It was you had the Pangea, the Pangea, I'm like a old-timey guy. You had the Pangea when all the continents were together, and you had this massive ice sheet that's forming. And so remember, the ice sheet forms and it's spreading outwards in all directions. And so you have evidence of that glaciation. And that's, one of the lines of evidence for continental drift was that you could look in South America and you could look in India and Australia and Africa, and you could see these striations. And they're all just haphazard and they're all kind of crazy. But if you put the continents back into their fit, back together as Pangea, they all orient themselves around a central point driving outwards like it's whatchamacallit, big old ice sheet. So
yeah,
so
you can see the glacial striations
yeah,
extending out. It's almost like spokes on a bicycle wheel.
yeah, that's a great way to mention. Yeah,
So-
it's all from this uplift. It's
So
great.
two things about what you just said.
Uh-oh.
Number one, Alfred Wegner's a friend of the podcast.
I make that assumption. He
Yeah.
would be.
Alfred Wegner died in 1930, dude. I don't think that even
Allegedly.
Allegedly. Okay.
His spirit lives on.
Yeah.
In
I
the,
believe he's looking down on us.
yeah, in the podcast.
Just giving us a thumbs up, like you guys are doing great. There was a second thing I wanted to say, but I can't remember it now.
Oh,
so.
perfect.
Oh well.
I assume it was praise.
It was just I wanted to tell you you're doing a great job, and you're really progressing the science right now, just in front of our eyes.
I was noting that he said coal, but more importantly,
Yeah.
and then followed up by something not involving coal. So
Yeah. I should have mentioned earlier one comment I did get from an actual alive friend of the podcast, Vince.
This wasn't via seance.
No.
A Ouija board.
He was pretty upset about how we were saying Appalachians. I don't know if
we should say
be saying-
Appalachians.
I wonder if we should be saying more Appalachians.
Mm.
Which
He should start his own podcast then.
I'll flip around. Ooh, dang!
I know.
I'll flip around depending on,
I'd say you say
the number.
Appalachian. I mean, we grew up near the Appalachian Mountains. That's the local dialect.
We did grow up in the Appalachians, but depending on the number of banjos and fiddle, I might call it the Appalachians.
All right, you flip flop all you want. I'm saying Appalachians.
Yeah.
I've been to my fair share of shindigs.
I think you gotta pick one of them. Like you don't hear somebody say tomato and then the next sentence tomato.
I've definitely heard the Caribbean, the Himalayas, the Himalayas.
I only know one person that says Himalaya. Okay.
I think we all do.
Yeah.
Do you know someone who says tomato though?
I do. I know a British person that says tomatoes.
Oh, I guess that's okay then. Not an American though.
I've never heard Americans say tomato.
No, I'm gonna try to say it all summer.
Yeah.
see how many times I get punched in the face.
I'll give you some updates on how my tomato plants are growing.
Exactly.
It just feels weird to say it like that.
I can't even do it.
Anyway, back to the Appalachian orogeny.
I don't know about the Appalachian orogeny,
Yeah.
but
Appalachian.
Alleghanian.
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 So anything else? Because I figured the second half, we're about halfway through the podcast. The first half talked about them going up. Anything else you want to add about the Appalachians going up? I think we pretty much covered it, to tell you the truth.
That's Africa, North America collide. Next thing you know, you got some mountains. Moving on.
Yep. To the first line of our outline. Mountains go up, mountains come down.
That's it. That's it.
The end.
So we've talked about this on the podcast before, but just to kind of, in case you're a new listener and haven't listened to our back catalog yet, Mother Nature hates topography. She can't stand it, and she wants everything to be flat and boring. I don't know why, but that's just what she does.
Yeah.
She hates pointy mountains sticking up out of the ground, and so what she does is she
also doesn't like big holes in the ground.
She doesn't like big holes. She tries to fill in big holes. She tries to break down the mountains, and she's on a rampage, filling in holes and breaking down mountains. So what a
rampage. I do feel like this is like a fairy tale story though. We got to find out why she has this anger and right the wrong.
I think she just has OCD. Just wants everything even.
Or it's just gravity.
I mean, doesn't she?
Yeah, or it's just physics, and there's no such thing as Mother Nature. Shh. Ruin it.
Yeah, it really takes away.
So even mountains that are actively growing are still actively eroding down. And so as soon as the mountain starts to grow, it gets eroded down. And the only way a mountain can grow is when the uplift is greater than the erosion. And so that's the growth rate of a mountain. So Mother Nature starts tearing this stuff down. And there's a few ways I guess the most common way is through frost wedging. Right? Basically, you get mountains are in cold. They're pretty tall, right? They're in kind of colder areas, and frost wedging is most efficient when you're at in an area where you get melt. The temperatures are above freezing during the daytime and below freezing at nighttime. But basically, water kind of trickles down through cracks within the rocks, and then temperatures drop below freezing. Ice is a really weird substance because it expands when it's frozen. What's the only other thing? Is it molten iron?
I think iron
does the same thing too.
I believe so, but I'm not 100% sure.
Yeah, I want to say it's iron, but off the top of my head. Anyways,
I did not know that.
Yeah, we might have mentioned it once before in the podcast, but anyways, so we're not talking about iron. We're talking about ice here, right?
Imagine if you had molten iron raining down on you. Bigger problems to deal with.
You got even bigger problems.
Weathering of mountains.
Yeah. So anyways, how frost wedging works is the water goes into the cracks of the rocks, it freezes, ice expands 9%, right?
Yeah, about that.
About 9%, yeah.
7.
Ice, is it 7?
Yeah, it's like 93. Yeah. So it might be 9.
Okay. It expands, all right. And so what happens is, as a result, this expansion, when the ice freezes, is really, really, really strong. And it kind of cracks the rock open a little bit more. All right. Imagine like the next day, the sun comes out, that ice melts, and it's able to kind of trickle down a little further through into the crack, and then so on and so on and so on. And next thing you know, over time, your rock starts breaking apart. Right.
There was a episode of MacGyver where he had to try to create a landslide to stop the bad guys. He put water into a crack of a rock and then discharge a CO2 fire extinguisher to make the water freeze and pop the rock off.
So good.
I'm telling you.
It is. You were right. 9%. I should never doubt you. Moral of the story.
Lesson learned. There you go.
Yeah, I'll never make that mistake twice.
So
are you still talking about frost wedging?
Go for some more, but go ahead. What are you going to say? You look like you're really excited about this next
one.
No,
I was going to say one of the things that happens during uplift, if you bring plutons up. So if you bring igneous rock that is formed in the subsurface, if you have molten, maybe from the volcanoes from the previous orogeny, some of that magma solidifies in the subsurface. If you bring that material to the surface, one of the ways it starts to break down is that it formed under pressure. So it's sort of squeezed all together. And then when it comes to the surface, it no longer is being squeezed together. It doesn't have that overburden on top of it or the rock to the side of it squishing it. And so it slowly expands. It's called pressure unloading. And so if you bring these plutons up, as it expands, as the rock releases this pressure, it cracks because rock does not like changing shape. And this is where you get the cracks initially for the water to start infiltrating in. So we're working together here.
There's a video. Do you guys ever see the video of the people watching the exfoliation dome? Like pop, I was like popping right in front of them.
Yes, it's incredible because you can hear it.
Yeah,
they're all going crazy. I mean, I would go crazy too.
Yeah, that would be. I wouldn't know what was happening. That would be crazy. Yeah. We'll have to post that. Write a note down. Post that video. Fun video of an exfoliation dome, like actively like cracking up in front of people. All right. So, anyways, these mountains they start breaking up. Mother Nature starts making little rocks out of big rocks. And then eventually this material breaks up, it falls down the side of the mountain. So if you ever look at like any modern mountain or whatever, you notice that there's something we call like a scree field at the bottom. And it's basically just all these big boulders that kind of just fell off the top of the mountain. And so that's kind of the start of these mountains breaking up. And then eventually the stuff gets broken up into smaller and smaller stuff until it hits like the sand and silt size, really, which we're dealing with mechanical weathering, physical weathering. And then you have the rivers at play, and the rivers start taking that material out and just start moving it away and starts transporting it. And I am doing a whole conversation here about the rock cycle, really, now that I think about it. So I guess the point I'm trying to make is that this erosion starts kicking in from day one as the mountain's being formed. And then all of a sudden, for whatever reason, just over time, your collision of the different continents starts to slow down, and the uplift of the mountain slows down until eventually the collision, the mountain stops growing altogether and erosion's taking over, right? So we know that Pangea is not a thing anymore. You can just look at any satellite image of the Earth, and you know that all the continents aren't connected together anymore. Eventually, what starts happening is the Atlantic Ocean starts to form, and this once convergent boundary where you had active tectonic collision turns into a divergent boundary. Now, the continents start spreading apart, and you start getting this rift occurring, and that is the start of the Atlantic Ocean. So if you want to look at like a good analog of what the Atlantic Ocean would have looked like when it was like a baby ocean, look at the Red Sea today. All right, the Arabian Peninsula is separating off of northeastern Africa, and the Red Sea is on this divergent boundary, and you get in this pulling apart motion. And so if you fast forward 100 million years from now, 100 plus million years from now, the Red Sea is going to be an ocean. So you look at the Red Sea right now, it's kind of this.
If you look at say you follow the Red Sea down, and then you look at into Eastern Africa, you see, all the long linear lakes that you have in Eastern Africa, in what's called the East African Rift Valley. You have all these rifts that all these divergent boundaries that are that are opening up, and so you have, I'm blanking on a lot of the names, like Lake Malawi and what are some of the other ones? Off the top of your head?
You stall for a couple seconds, I can figure it out.
Yeah. So these lakes are part of the continent splitting up. Lake Turkana is the big one. That's sort of
that's one I was thinking.
Humans evolve out of Lake Turkana, essentially. Not out of the lake, but in that lake valley.
Oh, like Swamp Thing.
Yeah. But if you look at a map and you see Lake Tanganyika, that's the other one. So Lake Malawi, Lake Tanganyika,
Victoria. Oh, Victoria, that's a little different. That's not one of those linear lakes.
Yeah, I'm not sure, but there are these long, deep linear lakes that are a function of the rift occurring. You would see that where Africa and North America were connected, and we had these long linear lakes that, the initial part of the Pangea breaking up, and we have leftover sediments from that, here on the East Coast. And we have names for them, we call them basins. So we have like the Newark Basin or the Hartford Basin or the Gettysburg Basin. There are these big former lakes. They actually represent parts of the rift that failed, where it started to rift and it created this divergent valley, but it didn't sort of keep rifting and rip apart. It just sort of filled in with sediment.
Yeah, it's like stretch marks.
Yeah, stretch marks. And
you're right. Yeah.
But part of that, part of these failed rifts, there's a lot of faults that are there that are then buried, and they create these sort of points of weakness where we have a little seismicity that that occurs every once in a while. You'll get one of these old sort of faults that'll just, you get a little slip on it. And I want to say that the major area here, and it's not from this one, it's from the breakup of Rodinia, which was, Neoproterozoic, so snowball earthish, before we were talking about after the Grenville, before the Taconic. One of these failed rifts is in New Madrid, which is, the New Madrid seismic zone is the major
Missouri.
Missouri. I was trying to think, I was like, Kansas, Missouri. It's right on the boundary of all those states, Missouri and Tennessee and Kentucky. And it's a failed rift like this that then got buried with sediment. And the weight of that sediment, every so often there's a big slip, and it's outside of an active plate boundary. It is the most hazardous spot for an earthquake.
I didn't realize that. That's pretty cool.
So you have these areas, and it's all a function of that ripping it up. And then did you mention how the whole coastal plain is from erosion?
No,
wait,
not
real
yet.
quick,
Didn't get there yet.
This fun fact of, I didn't realize, because I don't know my mythology well, but the Atlantic Ocean is named after Atlas.
I forgot to mention, yeah.
But Atlas is the son of Iapetus.
Yep.
So I'm sure it was the other way. I'm sure the Atlantic Ocean has been the Atlantic Ocean forever. And then whoever figured out that the Iapetus Ocean was there named it Iapetus, because Iapetus would have been the father of, but that's so cool that somebody took the time to figure that out, that like Atlas is the son of Iapetus, which is so apropos.
Well, yeah, we talked about that on the podcast about
talked
a month or two ago, right?
Iapetus is the son of Uranus and Gaia. So the sky, Uranus is the sky, god of the sky, and Gaia is the god of the earth.
Right.
And Iapetus is the son of them, and is the father of Atlas, Prometheus, and some others. They don't matter. No. Fire and water.
Well, that was one thing I didn't even know until recently, like within the last several months, what the Atlantic Ocean was named after. It was one of those things you just take it for granted for that name. You never.
No, you got to read your Percy Jackson novels.
Oh.
No, Percy Jackson. No, the Lightning Thief. They're movies anyway, and books.
You're so well read, Steve.
I am. I'm really up on my tween novels.
And just since we're on the topic here, Pacific means peaceful in Spanish. Mm-hmm. Pacifico is peaceful, and it's because one of those European explorers, when he first hit the Pacific, he hit it at like super calm, peaceful winds. And he's like, Mare Pacifico. He was Spanish. I don't know. Magellan, I think it was.
I think that's right.
That dude.
That guy. Just cruising around the oceans, doing bad things.
I don't actually know anything that Magellan. Anyway,
no.
Did he do bad things?
I assume was he killed by locals on some island? I forget. In the Philippines, I think.
But he was the first one to make it around South America, wasn't he?
Yeah.
From Europe, I mean.
His
first European.
His he made it around the world, right? They circumnavigated the planet. Well, I guess he didn't, because he got killed, but his boat did.
Ghost ships. Anyways,
Oh, we're all back to ghost ships now. We've come full
Nice.
circle.
Nice.
all right, let's I want to talk about the coastal plain and
Ghost
then,
ships
but
piloted by Sasquatch.
thank you. I
Mhm.
want to talk about the coastal plain and but just first a couple little fun facts about the Atlantic Ocean since we're talking about the Atlantic Ocean opening up. Okay, fun facts. Average depth of the Atlantic Ocean, 3,646 meters, which is for the Americans out there, 11,962 feet.
Pretty deep.
Yeah.
Deep open.
That's the average. That's crazy.
Average depth, 11.
Yeah, I was
Okay,
gonna
let's
say
say
12
12,000 feet. Yeah,
I was going to say 12,000, but I'd be way off.
you would have been off by 38 feet. All right. So that's the average depth. You guys know where the deepest part of the Atlantic Ocean is?
I do, but I just taught oceans in my sedimentary class on
Oh.
Tuesday. Sorry.
So where is it?
Oh, well, Steve, since you asked, the Puerto Rico Trench has a depth of 8,376 meters, or once again for the Americans, 27,480 feet. All right, Jesse.
27,480 feet.
Yes.
27,000.
20,000. Sorry, 27,000.
Yeah,
excuse me.
I said in class, I said something like, it's 27,000 and a half feet. And I was like, that's not how you say any of that.
Which actually 27,000 and a half feet is
Is 27,000 feet plus a half a foot.
it's pretty deep
27,006
because the Marianas Trench is 36,000 feet deep. I believe.
I feel like they just changed it. They
Let's
just
see,
keep
depth of Challenger deep.
challenge. And do you
36,200 is the first thing that pops up on Google, but that's from NOAA. So
Oh, they're good. They're good.
What do
That's-
they
that's-
know?
okay. How much water do you think is in the Atlantic Ocean?
Oh, I don't know this. A lot.
4 billion gallons.
Geez, let's see. 310,410,900 cubic kilometers.
What does that even mean?
Exactly. It's just it's a lot of
And
it's
where
a
do
lot
they
of water.
stop the Atlantic Ocean?
Yeah. Do they count the Gulf of Mexico?
This does include this. Yeah.
So does it draw a
it's-
line at the Drake Passage?
Oh,
But then
well-
it's the north part that I'm have questions about.
Well, the next stat down for shore length, they include the shore length for marginal seas. So I don't know. There's a lot of water in the Atlantic Ocean. These are just fun facts, or I don't like.
It's not a fun fact. It's making me angry.
Yeah.
No, I enjoy that fact. I want to know how many times can I fill my bathtub up?
How many elephants would that be, right? How many elephants could we fit into the
Did we
Atlantic
do that?
Ocean?
Yeah.
I looked up the weight of like a cumulonimbus cloud, and it was like it would be 40 elephants. I was like, I don't know how much an elephant weighs. Tell me in numbers I know.
I'm sorry. I thought you were an ivory dealer.
Yeah. what? Jeez.
Oh,
So
man.
when we talk about the Atlantic Ocean splitting up, it kind of split open in like two phases, basically. The central and North Atlantic Ocean split open first. So basically, North America splits off of Africa first. And so
And this is right. This is in the Triassic. So this is like 200
Yeah.
million years ago.
nailed it, 200 to 170, somewhere between 200 and 170 million years ago.
Yeah.
Yes. So, and then the South Atlantic Ocean, that starts to split up a little later in the Cretaceous. I think I saw
100.
110. Okay.
Yeah, right at the Aptian to right in the Albion to Cenomanian, because that was a lot of my PhD work was on that time period.
Oh, okay. There you
And the
go.
opening of the South Atlantic affects climate. Has a pretty drastic effect. Did the ocean have a name when all the continents were united?
We got a questioner from a Patreon listener. Good Good friend of the show, Mark. Yeah. So
Yeah.
you know,
Yeah. When it was Pangea, what did they call the ocean?
It was called Billy.
it was not called Billy. It was called the
Panth-
Panthalassa.
Panther. Yeah.
Known as nickname was Billy.
But then there was also the Tethys Sea too, as well. Tethys
Come
on.
Sea.
Billy Ocean. Come on.
I'm not even listening to him anymore.
And Panthalassa, pan means all, and thalassa is just Greek for sea. So it's all sea.
Oh, how about that? Look at you. You're really getting the origins of these names here today. It's crazy when you look into this. I know this is off topic, but when you look into like where the names come, everything has an origin for its name. It's not just like people just making like weird stuff up. There's some really, really interesting stories about where these things get their names from.
Yeah, I agree.
All right.
The etymology of things.
Yes.
So, yeah, and the Tethys was basically during the Mesozoic as things, you know. So I guess the Tethys was part of the
Tethys was like an embayment of like a huge embayment of the Panthalassa Ocean.
So Tethys was a Greek sea goddess who was the sister and consort of Oceanus.
Of course.
Who was the Titan son of Oceanus, son of Gaia and Uranus. So Oceanus and Iapetus are brothers.
How about that?
Fun. Yeah.
All these fun facts here at the Geology Flannelcast.
Tethys is the mother of all rivers and lakes and fountains of the world. I like how they throw in fountains in there with those Greeks.
Do waterfalls count as fountains?
I don't know.
Yeah,
you throw waterfalls and geysers in there as well.
That's the Greeks that was unknown to the Greeks, the ancient Greeks. I'm sure the modern Greeks know what a geyser is.
Another fun little fact about the Atlantic Ocean: the first reference of the Atlantic Ocean comes during the mid-6th century BC.
How about that?
They've been calling it Atlantic Ocean for a while now.
That is a fun fact, yeah. And you got this dopey Magellan coming around here in the 1500s calling it Pacific Ocean. I've always said the Atlantic is the better of the two big ones.
Looks like the Greeks named the Atlantic Ocean first. Oh, those Greeks. All right, let's talk about the coastal plain.
That would make sense since it was named after a Greek god.
It's good. Yeah. How about that? Okay. So the Appalachian Mountains, where did they go? They were there's a little bit left now, but
you can still go skiing.
Yeah, you go. Yeah. There's so most of it's been eroded down. The Appalachians been around for a really, really long time. And at this point now, most of it has been eroded down. And like where the main part of the Appalachians is actually where the modern day Piedmont is, where you get obviously the mountains aren't there anymore now, but there's a band of metamorphic rock going up just adjacent to the east of the Appalachian Mountains today. But that's that metamorphic rock that's exposed, what we call the Piedmont, is the roots of the mountain chain. So it's not there anymore. Where did it all go? Mother Nature tore it all down. She got really angry, tore the whole thing down. And we have these huge sedimentary deposits today. So we call this, when we get these giant sedimentary deposits being, the mountains being torn down, and that sediment of the torn down mountain gets deposited adjacent to where the mountain used to be. We call this a clastic wedge. And we see in the Appalachians. So that's one other reason where we know about the previous mountain ranges. We see these giant clastic wedges in the rock record, right? So how big? I know the Catskill Formation from the Acadian orogeny, that's like 6,000 feet thick, right? 5,000 feet thick?
Yeah, like it's thickest. Yeah, it pinches.
Yeah, and
Yeah,
it
yeah,
is
that's-
pretty amazing how, based on these different orogenies, that the mountains were built, and then the mountains were shed, and then some of the sheddings actually become mountains, and the other parts become valleys, and then the volcanic deposits, like just the the whole process is so complex. It's ridiculous how these scientists can
Yeah, I know.
basically reverse time and figure it all out.
In parts of the valley and the ridge of central Pennsylvania, some of the peaks today are the former valleys,
Right.
because that's where the resistant rock was, and the less resistant has eroded away. That were the former peaks of the mountain. And you can see this by looking at, say, the structure and how the rocks are folded. You have these anticlines and synclines, and you could see where the former, how the mountains would build up, but that is all eroded down. So that was always a little bit mind-blowing to me. You go out there and you look at these peaks and you're like, well, that's the valley.
Right.
So in between those peaks is where the mountain used to be.
Yeah. So you have to be able to do like little mind tricks to visualize it in reverse. Yeah.
It's tricky. It's not easy. So
Um,
what about, so the you could say like the clastic wedge from the Appalachians would be the coastal plain of today on the east coast of North America. So the east coast of North America has a really extensive coastal plain. Jesse, with the stuff that you worked on, how thick was that, the coastal plain? And stuff through there?
Yeah, I mean, you go down off you go off South Jersey there, and you hit like of sediment. It's like 8 kilometers or something.
Yeah.
It's
It's huge.
Yeah, that's enormous. Jeez, oh
Yeah.
me's. So you give that a couple million years, that'll turn into, well, some more million years.
Yeah.
That'll eventually turn into rock, lots of sandstones, and that's
Speaking from an environmental consulting end of it, like you get a Dean apple in South Jersey, it just
see ya. Goodbye.
it doesn't stop.
Yeah,
It just goes.
Forget about it.
Yeah, exactly. Forget about it. Yeah.
If you look at a cross-section picture of South Jersey, it's just like this layer cake wedge.
Yeah.
Everything.
But
thick and,
but that layer cake wedge, that thick sand body is a great aquifer. It's a great source of water for a lot of the state. So again, put that in your paper for economic value.
Yeah.
The water.
Got the Kirkwood Cohansey, and you got the Potomac Magathie. Great aquifers. Some of my favorites.
I Googled the thickness of the Atlantic coastal plain, and it said it was 185 feet thick.
Well,
That's the wrong thing, obviously, but I looked at that number. I was like, that's not right. Something's not right there.
You hit the mantle after that.
Yeah.
Whoa. This is saying is this correct? In Maryland, they think the sediments attain a maximum thickness of 40,000 feet.
Yeah, it's about right.
40,000 feet?
40,000 feet.
You figure, well, that might be a lot, but like, I mean, in Jersey, off like Atlantic City, you can get 8-10 kilometers, and what's that? That's like 30,000 feet.
Wow.
So, I mean, I feel like you're spending some time here on the coastal plain, and the beaches of South Jersey, and all of South Jersey is essentially made up of this shed sediment. Lest we forget, on the western side of these slopes, we have a big flat table of sediment.
You're right.
What do we call that?
Plateaus? Is that what you're getting at? Yeah. We have the Cumberland Plateau and the Allegheny Plateau.
Yeah.
On either side. So the Cumberland Plateau is like in Tennessee, up into Kentucky, and up into West Virginia. The question I got a question for you guys.
Oh dear.
Is there a set divider between the Allegheny Plateau and the Cumberland Plateau, or is it just kind of a regional thing?
Huh.
Is it just one big plateau kind of extending out, or is it?
Or is that the Blue Ridge sticking in between there?
Yeah, is there what's is it where I don't know. Is there a river where's the Ohio? No, that's gonna be it. Yeah, it looks like it's just I don't know, people down in Kentucky.
Well,
Yeah.
it goes all the way north, and then somewhere in West Virginia, I think they switch it over and they start saying the Allegheny Plateau.
Well, it's like
Yeah.
sometimes when you have a rock formation in one state and then across the state lines and it changes names.
Where
Like,
But I think I'm
this
pretty
is
sure
no longer
southern.
this formation, it's now this formation.
I want to say off the top of my head, and take this with a grain of salt, but I think southern West Virginia, they still call it the Cumberland Plateau, but then in like northern West Virginia, it's the Allegheny Plateau. And definitely once
Yeah.
you hit Pennsylvania, it's obviously the Allegheny Plateau.
I would say a lot of West Virginia and Northwest Virginia. Yeah, it looks like there's no real geologic difference. It's just historic usage.
Okay.
Yeah, if I love looking at either a geologic map or a topographic map of these plateaus where you can see the rivers that are just
Oh, yeah. The rivers cuts through.
Oh
yeah.
yeah.
cutting straight
Forget the
through.
river runs through it. The river cuts through it.
Yeah, it's just incising out the wazoo.
Yeah. It's just like all these like spider veins and yeah. Looks very cool.
So these plateaus we're talking about are these giant like deltaic sequences of just material that's being shed off of the Appalachians to the west. And I mean, you want to go see some beautiful like delta deposits, Kentucky, man. Whew, all over the place in Kentucky. Tennessee has some really, really neat stuff, but you get a lot of these like sandstones and conglomerates that are forming. And it's all the stuff that's just draining off of the Appalachians. So there is a ton of sediment that the Appalachians left behind. It left quite the I don't know. There's a lot of it, there's so much when you add up just kind of the volume of those two the Cumberland Plateau and Allegheny Plateau plus the coastal plain on the other side. That's a lot of material,
Yeah. And if you just open up Google Earth one day and it kind of, or at least for me in the United States, it kind of zooms in on like a big satellite view of the United States. But if you look to the east, you can see like this light blue edging all the way down the entire coast, the entire east coast. That is that coastal plain. So imagine, if you were to drain the ocean a little bit, the beaches would extend basically out to that light blue area. And even when, obviously there's not as much erosion and things like that, but when you look into those light blue areas, you can see during the last ice age where those rivers cut into it. And essentially that's the same thing that was kind of happening on the west side as well, but obviously much more prevalent because it's not covered by a giant ocean now.
Yeah.
So yeah, just do yourself a favor. Just go on Google Earth, zoom into the ocean near like New Jersey or Maryland or Virginia, and you can see all this stuff. It's really pretty cool.
Then go look at the Allegheny or Cumberland Plateau.
Yeah, in topographic, yes. I have a big geologic map of Pennsylvania. It is fascinating.
So I got one other fun fact. Well, about kind of this coastal plain eroded remnants of the Appalachian Mountains. So if you look at, and it's really interesting how geology has controlled human infrastructure. I'm always like amazed by how humans build around, and it ends up being the humans end up following the geology, right? So you look up the major cities along the U.S. Eastern Seaboard. All right. So we got cities like, starting in some of the biggest ones are starting in like Virginia, right? We got Richmond, we go up to DC, Baltimore, Philadelphia, right? Going all the way up into New York. These big cities are all on the edge of the Piedmont. It's basically they're where the Piedmont meets the coastal plain. And so we call this the fall line. And the reason that it's called the fall line is because the rivers that are draining off, like the Potomac in Virginia, we have this area called Great Falls, right at the fall line. You tend to see not so much like you think like fall line, you think you'd see like waterfalls, but you see like a lot of rapids and things like that, some white water or whatever. And it's just from the rivers draining from kind of like the older metamorphic crystalline rock, and then all of a sudden then it hits the flat coastal plain. So that area is basically where the coastal plain hits the Piedmont. It's called the fall line. And all these major cities were built on the fall line. And the reason that they're there is because when the United States was being colonized, the Europeans were taking their ships up the rivers, and they basically hit these points. They hit the fall line, and you couldn't get past it. And so they said, "All right, that's cool. We'll just build our city here, and that's it." And that's why these major cities are where they are. They took the rivers up from the ocean, took them across the coastal plain, hit the fall line, couldn't pass it, and they said, "This is it. Good to go."
And some of that also has to do with the fact that they were taking advantage of the fall line. They were putting mills and
sure, yeah,
all different kind of industrial processes where they were using that drop of that potential energy, that water dropping down. They were using it to spin turbines, to spin mills, to basically produce. You look at like the Brandywine River. There was all kinds of, there was something like 150 mills on the Brandywine River just between like the Pennsylvania border and the Atlantic Ocean. So that fall line, yes, they couldn't get their ships up further, but then they were also taking advantage of that big drop in topography to power essentially the Industrial Revolution.
It's interesting. I mean, even the Appalachians further a little bit to the west, the barrier they acted as until the early to mid 1800s, they were a major barrier towards like westward expansion. How did most people get to California in 1849 for the gold rush? They got on ships that went around South America.
Really? Holy.
The Transcontinental Railroad wouldn't come about until I want to say it was 1869. It was after the Civil War. So like the majority of people traveled by ship for like, in 1849 for the Great Gold Rush in California. Like these mountains acted as they were a significant barrier. Even just putting a train across the state of Pennsylvania was like this technological. That's why like the Erie Canal or what was the big canal in Pennsylvania? The one canal that basically traversed these things were.
Is that the Cno Canal or Cno?
Yeah,
two letters, right?
Yeah, I think you're right.
Yeah, I think it's.
There's the C&D Canal, but that's in Delaware. That connect the actual Delaware Bay with the Chesapeake Bay. That's why it's a C&D Canal.
Yeah. But I think, but like these are technological achievements, like to get westward expansion. It's kind of crazy when you think about, the Appalachian Mountains, and then you get people traveling west and wait till they run into the Rocky Mountains.
It's the Cno Canal, by the way.
That's
Chesapeake and Ohio Canal. That's what the Cno stands for.
There it is.
I never knew that. I just never thought to ask why.
but through a lot of these orogenies too, speaking of rivers in Pennsylvania, you have that Susquehanna.
That's a weird one. Yeah.
There are lots of literature out there that says this might be the oldest river on the planet.
Yeah.
Now, the Susquehanna dissects the Appalachians, right?
Yeah.
Right. Which means it was there while these orogenies were happening, or at least the latest one. So you're talking, it's at least 220 million years old.
It's an old river. And then the New River as well is the New River dissects. The New River is a really old river. The New River is just, could be potentially that old as well. It's one of the oldest rivers in the world. And that also dissects the Appalachian Mountains. And the interesting thing about the New River is that its headwaters on the east side of the Appalachians, and it crosses over the Appalachians and eventually hooks up with I think goes into the Ohio, but eventually it goes into the Mississippi and out the Mississippi Delta. So it's, I think it's the only river that crosses its headwaters are east of the Appalachians, and the mouth of the river is at the, it ultimately dumps out the Mississippi Delta.
Yeah, very cool.
Well, I think that extensively covers the Appalachian Mountains.
Yeah, and I tell you what, one day we'll have to do a episode on the fall line and the whole I-95 corridor and how it pertains to weather.
Oh yeah, the I-95 corridor.
You don't know how many times you hear it on the news, like, oh, and the snow's going to follow that I-95 corridor. And it's not just because the snow's like getting, directions from Waze. It's because of that fall line. That fall line is, there is a topography change. And when there's even just a slight 20-foot topography change, you may get a difference between snow and rain. So
crazy. And the other thing, I wanted to mention this before, but I-95 connects all these major cities, which were, built right on there on the fall line. If you want to know where the fall line is on the east coast of the US, where you get that transition from Piedmont to coastal plain, just follow I-95, like follows it nearly to a T. You can actually see the fall line also at nighttime from like a satellite image of the Earth. You can see just all the lights from all the cities, and it you can see it shows it's right on the fall line. Brings out the fall line.
There you go.
That's it.
The more you know.
There. So, any other fun facts about the Appalachians? I think that's it.
They're my favorite mountains.
We have a podcast documentary here that rivals anything that Ken Burns did. And I'm going to go ahead and say that this is a timeless podcast on the Appalachian Mountains.
No, I can put a date to it. It's about 1 billion years old.
Well, if you want to go back to Grenville, but
yeah.
Anyway. Yeah.
All right. Yeah. Thanks, everybody. Thanks to all our Patreons. We had a couple good questions during the podcast today. We really appreciate that. If you'd like to become a Patreon, please check us out. Patreon.com /Geology Flannelcast. We're on Twitter, Instagram, Facebook. I don't know.
GeologyFlannelcast.com.
Obviously.
Follow us on YouTube too. Watch the videos.
Subscribe to us on YouTube. Yeah. Drop us some comments.
If you do send us messages, like a message from a person on Instagram I just never responded to yet. I'm going to get there. I'm just really bad at it. Who was asking a question about rare earths and other sort of economic minerals. It's a great idea. We'll probably do
that is a great idea, because there's a lot of green energy that requires a lot of mining, which sometimes mining is not green. So, as far as your carbon footprint, I guess, what's the cost benefit ratio and all that stuff. So yeah, it's a very interesting topic. So keep them coming. Coming.
Thanks, everyone. Also, if you're interested in helping out the podcast, we got some merch up on geologyflannelcast.com as well. Go check that out. Steve, where's your Flannelcast t-shirt? Normally it's in the background.
It depends on the level of work call that I have. If it's really important, I put it down. If it's not important, I keep it up.
There you go. So we got mugs, t-shirts, stickers, fun stuff, hoodies too. So anyways, thanks everyone so much for listening this week to this episode of the Flannelcast. And we will catch you guys next week with another fun and exciting episode of the Geology Flannelcast. Thanks so much. We love you guys. Thanks for listening, and we'll catch you next week. Bye.
All right. Thanks a lot.